Do you guys know where that comes from? Think about the quadratic formula. This, under the radical, is actually discriminant. Opposite of b over 2a is that first term of the quadratic formula. Alright, so if we do that, -6 over 2 times -3, we get 1. Have to plug that back in. We get 4. So the vertex is order pair 1, 4. Axis of symmetry is x equals 1. Has to be the x value of the vertex. Does this open up or down? Down. I didn't ask this, but does that mean it has a maximum or a minimum point? A maximum. If it's opening down, it has a maximum point. What is the maximum point? 4. The highest y value we get is the y value of the vertex, 4. Alright, b. Opposite of b over 2a. We get 1. Plug that in. And we get 3, so the vertex is 1, 3. Axis of symmetry is x equals 1. It is a line, so you have to have the x equals. Does it open up or down? Up. So does it have a maximum or a minimum? Minimum. What is that minimum value? 3. Last one. Opposite of b over 2a. So we get a -1/4. Have to plug that in. So -9.5 or -19/2. Axis of symmetry. X equals the -1/4. Does this open up or down? Any questions on this? So the next thing we're going to look at just some quadratic models. So quadratics are very common with modeling motion. You know, if you take a ball and throw it up in the air, what's going to happen? At some point, it's going to turn around and come back down, right? So it kind of makes the path is like a quadratic because it's going up and then it's coming down after a period. And so we see them a lot. When we're looking at quadratic models or quadratic equations to model scenarios, the vertex is always our maximum or minimum. Specifically, what we're going to be looking at today, the height of an object can be given by this equation. So that kind of comes from physics. The -16 is actually due to gravity, so that's set. So -16t squared plus b sub 0t plus h sub 0. In that the t is time, the s of t is your height. V sub 0 is beginning velocity, h sub 0 is beginning height. So you can fill in all the blanks on your paper. Let's look at a problem. A ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. So, this is that equation we just wrote down. give it a function that describes the height of the ball in terms of time t. In this quadratic equation, the v sub 0 and the h sub 0, you have to plug in those values depending on your problem. So v sub 0 is our beginning or our initial velocity. What is that? 112. H sub 0 is the beginning height, which was 75. Okay, so now we have our quadratic equation. What if I said it started on the ground? What would your beginning height be? 0, good. What if I said we had a ball and we just dropped it? What's your initial velocity if you're holding it in your hand and then you drop it? 0, because you didn't actually throw it with any force. So at the beginning velocity in that case would be 0. So it is possible for those things to be zeros. Okay. After how many seconds does the projectile reach its maximum height? Okay, if we have a quadratic, how do we find a maximum? We can do that using our formula. So we typically say x equals, but in this case my variable is time, opposite of b over 2a we get 3.5. So it takes 3.5 seconds to meet our maximum height. How do I find the actual maximum height? So if we plug that in, we get 271, and in this problem the height is measured in. Is that okay? Next. For what interval of time is the height of the ball greater than 200? So the height is given by this equation. And I need that to be greater than 200. Okay. How could I work that out? We actually subtract the 200 over. So we could bring the 200 over and then try to factor it. Remember, we've done this quadratic inequalities before. Sometimes these answers aren't very nice, so I wanted to teach you another way of doing them from your calculator. So, on your calculator, I want you to go to your y equals, and your y sub 1, we are going to enter the left-hand side of our equation. So negative 16, we have to use x for the variable, x squared, plus 112x plus 75. And our y sub 2, I want to be the right-hand side of the equation, which was 200. if I just look at my graph right now, I'm not seeing much of anything because my window isn't set correctly. So let's go into window. So it's probably on the standard window, -10 to 10. My y's, we're setting this equal to 200. So my y max needs to be bigger than 200. So maybe I'm going to go to y max, I'm going to change that to 250. And then right underneath that it says YSCL, that's your scale, what it's counting by. If you're counting to 250 going by ones, it's going to take your calculator a little bit. So I'm just going to change that to 10 to help speed things up a little. And then let's look at our graph. So the blue is my parabola. That red line on mine is the 200. Is everybody okay? So when looking at that on your calculator. So we wanted to know when the height was greater than 200. So can we agree it's greater than 200 for this little section when the parabola is above that red line? We need to find these 2 points when it actually equals 200. So to do that, we can go into second, trace. Okay, these are all the things your calculator can find for you. If we're looking for when two things meet, which one do you think we want? Intersect, number 5. Okay, now it asks us some questions. The first curve, up at the top you see, it says the y1 equals, it's the first equation we entered. Just push enter. Second curve, it will automatically go to the second one. So just hit enter. And then the last thing it's asking me for is a guess. So these graphs go on forever, not just what we're looking at forever. So we need to narrow things down for the calculator, so just get close to your point and hit enter. And so then it tells me the intersection is 1.393. So it's between 1.39 seconds and now we need to find this other one. So we repeat. Second, trace, intersect. First curve hit enter, second curve hit enter, guess. Now get closer to that second point. Hit enter. And that intersection is 5.61 seconds apart.
You want to surround that with these?
You can. I just usually go to the nearest 100. So just follow your typical rounding rules.
Did everybody get that to work? D, after how many seconds will the ball hit the ground? If you hit the ground, what is the height? Okay. So we could do this by hand, trying to factor quadratic formula. Let's do it on the calculator for practice. So if we go to our y equals, the left hand of my equation stayed the same, but what should my right hand side be? 0. There are other ways to do this, but I figure it's easier to do it the same way as we did the last one, rather than trying to do a bunch of different things. So then if we look at our graph, we have the parabola, but now my second one is 0. Now, technically they meet in 2 places. Which one are we looking for? Yeah, the one over here. Can you even have a negative time? No. Our original path, we started at 75 and then it traveled like this. So we're looking for when it comes back down over here. So we go to second, trace, intersect. first curve, just push enter, second curve, just push enter. Your guess, we need to get all the way over to this point. Push enter. So we get 7.62 seconds. Questions on that? I have another one. I didn't print another one on your notes handout, but I have another example. Do we need another one like that? You guys were able to get everything to work on your calculator, okay? So, real quick, quiz tomorrow. So your quiz, we have all of the complex numbers. So if I said like 5 plus 3i over 2 minus I, what would you do to write that in standard form? Multiply by 2 plus I on top and bottom. So we get 10 plus 5I plus 6I plus 3I squared. On the bottom you get 4 plus 2I minus 2I drop minus I squared. I squared turns into, so this is 10 plus negative 3. 7. I plus 6i is 11i. 4 minus negative 1, so 4 plus 1 is 5. Is that how we leave our answer? No, we have to separate them, because I would say write it in standard form, so it'd be 7 over 5 plus 11 over 5i for the final answer. What if I gave you this? Just tell me what we're. Right. This is the one that everyone. I told you that people will multiply them, and you guys laughed like you would never do it, and then some of you did as well. Yes, it's very easy to do. Now it's a plus, so we're just adding like terms. So 5 plus negative 2, 3i plus 1i is 4i. What if I gave you let's do this. How would you write that in standard form?
Take the I out first.
Okay. So we know because it's the square root of a negative, you would have an I. Okay, how can we break down 54? So it would be 3i, 5 plus 6. So if we break them apart, we have negative 8 over 3 minus, those the 3's would cancel, so just I radical 6. What if I gave you I to the 81st power?
Squared to
have to break it into I squares. So we can make 40 groups of 2 and 1 left over. Squared is -1. -1 to the 40th power.
1.
And 1 times I gives you I. So that's kind of all the things with the complex numbers. Are we okay with those? The second part of it would be all the quadratic stuff, which is what we are practicing right now. So I'm not going to do any of those, but you have homework that will practice that stuff. So if you look on Google Classroom, there's a handout posted, and you have the rest of the hour to work on that math